Yep, so welcome everyone. This is 3D Printing Owner's Manual for FDM and PolyJet. So the goal today with this presentation, this webinar, is to give people an idea of what it's like to own a printer, what work is involved, what kind of time investment, day-to-day, taking care of the machines, taking care of material, what post-processing might be required for your parts, what other units, machines, systems that you might need. So yeah, I just want to give everyone a kind of quick comprehensive overview. FDM and PolyJet machines, what does it take to own one of these? So my name's Robert French. I'm a mechanical engineer from UC Riverside, been with Go for about 7 years now. A lot of experience in machine design, CNC programming. I actually used to be on the CAM team. I see my buddy Richard's here on the call as well. He's on the CAM team now as well at GoEngineer. I've recently transitioned over to 3D printing, but have a lot of experience on CNC, CMM programming, operating those machines, and I'm in the San Diego office for GoEngineer. And you can all see my email down there, our French at GoEngineer. Feel free to email me anytime, questions, whatever you might have. Happy to help. So this webinar isn't your only source of information. Hopefully you know that. We have a lot of resources out there for you guys, not just the ones listed here on this particular PowerPoint slide. We have a huge YouTube page. You can see down below, another one of our colleagues, Michael. He's really, really knowledgeable, makes some great videos. For instance, that one there, PolyJet head cleaning. I'm going to show you kind of a little bit of that. Not going to go nearly as in depth of that video, but once again, we have a lot of those other resources out there going far more in depth on topics I'm just going to kind of give a bird's eye view on. We have all our applications engineers, like I mentioned, myself, Michael, Richard. Feel free to email us. We're here to help you get more knowledge, be more productive, really get the most out of any product you have through GoEngineer. And a lot of this information is just pulled from not only experience, but some of the Stratasys documents they have on their website. Happy to link those to you and get you that information. So just let us know. All right, so GoEngineer represents a couple 3D printing technologies. The ones I'm focusing on, obviously PolyJet and FDM. You can see a whole smattering of machines there. The J3555, some of the newer PolyJet styles, really cool. I have some cool screenshots that Richard shared with me. Show you a little bit about those. I have a J750 kind of upgraded to an 850 right behind me that you'll get a great look at here when I roll my sliding presenting table over to the machine. And then for FDM, kind of the old school, the OG original printing technology. In my office here in San Diego, I have a 370, F370, and a Fortis 450, two really great machines. So I'll give you a little bit of a webcam view of those as well. And we also have quite a few other technologies. We have our SLA machines in the Neo line. We have SAF, selective absorption fluid, which is the H350, printing some really powerful end-use nylon parts. P3, those machines in the bottom right, really cool technology, very similar to SLA, but kind of tuned up for some of the newer technologies, not laser sintering anymore, actually using a projected image, some really cool materials out of those machines as well. And then we have our metal printing machines as well through the Exact and Velo lines. So really cool technologies out there. Not going to get into those other technologies today, but as always, if you have questions, let us know. I'm going to launch a poll question here real quick just to kind of see what people on our call today are using. What kind of technologies do you guys have out there? Or if you don't have one at all, go ahead and fill in that poll question I just sent out. Curious to see, what technologies some of you are currently using. And if you're not using one, that's fine. It's always good to learn. All right, looks like 100% voted. I really appreciate that, everyone participating. So it looks like we have a pretty decent split here, or decent distribution. FDM and PolyJet, both of you, it's some of the most common technologies, some of the oldest lines we've represented here at GoEngineer, so quite a few using that, some other technology, and cool to see some people here don't have 3D printing and just want to learn. It's pretty awesome. All right. So the key topics today, once again, just what is it like to own a 3D printer? What is the maintenance, routine tasks to keep our printer running as best as it can, right? What are some of the day-to-day tasks or weekly tasks? What should I be doing to take care of my machine and keep it running its best? We're going to talk about support removal and post-processing. What do I do with the part once it's done on the printer? How do I clean it effectively and get it to where I want it to be, whether it's an end-use part or a form fit function test or jigs and fixtures? What are some of the other systems that I might need to do that? And lastly, we'll talk about material handling. There's some really nice materials out there, some of the true thermoplastics on our FDM machines like nylon 12 carbon fiber. How do we best preserve that more expensive material and make sure we're not wasting material at the end of the day? And also keep it in good shape for high printing quality. All right, so let's just talk about some of the maintenance to start before I jump to my webcam and show you a little bit of the hands-on stuff. So always keeping the machine clean, right? For FDM and PolyJet, we want to not let debris build up in there, and it gets a little bit more intense when it comes to PolyJet. We have a liquid that can kind of spill and fall different places and bunch up, and so we want to keep that clean, keep our print heads clean, and printing as effectively as possible. With both machines, we're talking about calibration or optimization. With FDM, we talk about tip calibration. There's two methods, automatic and manual. This is just making sure the print heads are lined up where the machine thinks they are and printing accurately. With FDM, we talk about purging heads. This isn't something that's totally required or kind of a routine thing, but often if the machine sat idle for a long time or doesn't seem to be printing effectively, I like to run a purge heads. Once again, if the machine sat idle for a little bit, make sure I'm getting fresh new material into the head, not material that's been sitting in that heated head, kind of just percolating and then, not being used. On the PolyJet side, we have head purging as well, getting fresh new liquid. PolyJet uses a liquid resin, so getting new liquid into that head, ready to print. And it gets a little bit more intense on the PolyJet side. It is a little bit more sophisticated of a technology. We have head optimization. I'll give you a look at that in a second. Making sure the heads are spitting out an appropriate amount of resin to be cured. And that resin is cured via UV light, at least on the 850 and 750 here. The J3555 actually cures using a LED, doesn't need to be calibrated, but want to make sure it's functioning correctly all the same and cleaned and distributing that light effectively. For both technologies, we're talking about updating our software on the machine to make sure it's got the latest up-to-date software and printing most effectively, staying in tune with the Stratasys standard. On PolyJet, I list Allen wrenches. For most of the maintenance you really only need a few Allen wrenches to kind of take apart a few of the mechanisms and assemblies on the top of the shuttle and get at replacing the roller bath, cleaning different things. Show you a little bit that here on the webcam in a second. I put vacuum for both machines. It's kind of optional. I mean, you can get most of it out just picking it up, grabbing with your hands, but we do have a nice shop back here, and it definitely makes it easy. Just go in there and clean out any extra debris or residue. All right, so when we talk about FDM calibration, the manual method the automatic method is going to go ahead and just kind of touch off the print heads on the build tray, make sure they know the Z height adjusted correctly. And I run that pretty often because it's automatic, right? I just have to click it, walk away for 10 minutes and come back and know my printer's been optimized at least somewhat. But if we're really looking for high accuracy, we can go with our manual calibration. And this is what's going to print right here. We see this grid of kind of XY coordinates printed out of model material, and then we see a thin white strip of support material kind of laid on top of that. To the side, I have my magnifying glass, kind of lets me zoom in and see, because what I'm actually going to do is look for where that support material falls inside of two other model channels, and where it falls dead center inside of those two other model channels, I can take those numbers, punch them right into the machine, and fine tune my FDM accuracy even more. So those numbers represent tenths, right? So tenths of a 1,000th of an inch, so 4 decimal places over. So I wouldn't call this something routine, depending on what your application is. If you're looking for extremely high accuracy, this is mandatory. But if you're printing out something that's a rough gauge, then it's not something I would feel urgency to do before every print. I mentioned before that the PolyJet machine required Allen wrenches. I didn't list any tools for FDM maintenance because changing out a head is toolless, right? We got some cam locks and stuff like that on the top of the machine where the heads go in. No tools required in order to perform that maintenance. But if you're going to change out heads, it is required to at the very least, run a automatic calibration. But I would certainly, if I changed out a head, recommend running the manual calibration as well. So I mentioned updating the software for each of the machines. This can be done through GrabCAD Print. Hopefully everyone here on an FDM and a PolyJet machine is using the GrabCAD Print software. It's all you need. It's a great slicer, really good for manipulating toolpaths and changing support, model infill settings, all of that, and can be used to push your software updates to the machine. You can see there in the left-hand screenshot, I've selected my San Diego at the bottom of that screenshot, San Diego F370, and jumping into the settings, I see, hey, new firmware version, new software for the machine, and I can push that to the machine from any computer linked on the network, right? Any network-linked computer to the network-linked FDM machine. Some of those routine maintenances I mentioned for the PolyJet machine, whether it be head cleaning, head optimization, whatever, it's found in the kind of Stratasys onboard computer, at least for a J750, you can see right there. I do have a screenshot in a sec for the 55, but we can find all those wizards in that drop-down menu for maintenance. So these great screenshots that Richard shared with me, we can see we have a little bit more of a interface screen, right? Touch screen, as opposed to a kind of standalone desktop computer that goes with our bigger units. And we can find in tools, wizards, in that middle screenshot, we see routine cleaning, head purging, head replacement, right? And pretty straightforward, pretty guided kind of maintenance experience there. We don't have to go read a manual or anything. We're just being guided right on screen as to what to do. So this is something on the PolyJet machine that I would run, once again, depending on how active the machine is. If I haven't ran it in quite some time, maybe a day, 2 days, this is something I would consider doing to ensure I get the highest quality out of the next print. But if your machine's constantly running, you're not letting liquid resin sit idle in the heads for an extended period of time, prints are just go, 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 it's not something I would concern myself with as a necessity before each print, but something I would still probably run on a weekly basis. So once again, once we run these kind of head cleaning routines, we can see in the screenshot on the left, the J55 and 35 are actually really cool new machines. They're no longer kind of an XYZ machine, right? Heads moving left to right, up and down, front to back. It's actually a circular build tray, and the build tray rotates. So you can kind of see the positioning of the components in the left-hand screenshot there. In the bottom left corner, we see the print heads. In the middle of the screenshot, we see the roller. This kind of comes over the top of the printed layer and kind of smooths it out. And in the top left corner, we see the curing LED lights. On the right-hand screenshot, we see just a simple wiping of the print heads. We're using isopropyl alcohol and a lint-free cloth. It's pretty important you use a lint-free cloth. Those print heads have very, very tiny holes, about 192 of them now on the newer print heads. They doubled that from 96, so really high resolution. And we don't want to plug them. We don't want any kind of little dirt or cloth filament or fibers. So that's why we use those lint-free cloths to make sure we're cleaning those as well as we can. All right, let's jump over to the machines now. I'm going to switch to my webcam, so hopefully you all now see me nice and big, and this rollover goes nice and smooth. You can see my big J750 here, pretty big build tray. And we're going to tilt down so you can see some of the machine and different things I use to optimize it. So in that wizard I showed you a moment ago in my PowerPoint, we had an option in there to clean the head, or move. You can even just move it to the head cleaning position. Lowers the build tray, puts the shuttle right in the middle, and that gives me access underneath to the print heads, roller, and things like that. Now we have a mirror, comes with our machine, lets me kind of not have to stick my head in the machine, right? Not safe, but you actually can see pretty well. I'm happy that worked out. The 4 print heads that we'd want to clean. To the side of those, we see the roller, and just underneath those yellow triangle stickers. And in here, of course, I have my isopropyl, my lint-free cloth. Simply apply some on there. We're going to wipe all the heads. We're going to wipe the roller. We can rotate the roller as well. There's a little gear here, or we can just rotate the roller underneath as well. Make sure we get that nice and clean, no residue. Also, on both the J3555, 75850, all the PolyJet machines, when you actually run a head cleaning operation, this tray over here is the purge tray. Every so often during a print, it'll come over here and squirt some fluid out, keep the nozzles fresh, clean, good to go. We'll see some rubber kind of wipers, so the heads will actually rub across those wipers and make sure they get nice and clean all throughout a print, right? Keep it nice and clean throughout the print, right? That's a big theme, obviously. I've repeated it several times, but just keeps our print quality up. When we run a head optimization wizard, something the PolyJet machines will do is take use of a scale. The tray will be lowered completely. It's actually really cool. It'll print right on your build tray instructions, right? Right on the build tray, out of print material, it'll say place scale here, right? You know exactly where to position the scale. There's actually some cable attachments inside the machine to power the scale, gather the data, and we'll put our liquid fill tray right on top of that scale. And the print head, the printer will kind of take care of this routine for head optimization. It'll squirt liquid out. It's measuring how much is coming out, so it knows it's fine-tuning its pressures, right? It's squirting some out, weighing that amount. It has an expected amount of how much it thinks it squirted out, kind of does a feedback loop and takes that information, and you might see on your machine controller running iteration number 1, iteration number 2, right? It's repeating that process until it finally fine-tunes its pressures, fine-tunes the vacuums, and makes sure you're printing out the correct amount. Before that routine, on both PolyJet machines, it'll do what it calls a pattern test. It'll test all the nozzles, printing out these strips. It might be kind of hard to see. I don't know if I can get it on screen too well, but you're basically looking to see that these are fully filled in, right? Each line, each nozzle, each little microscopic hole on each print head is squirting out liquid. I had one nozzle fail. I don't know if you can see that, it's pretty small. But before I run this head optimization, I'd take that data and kind of give it a first head start of, you know, where is there some missing pressure, missing nozzles. So a pattern test, having these pattern sheets, piece of paper, good stuff to have for your kind of routine use of the machine. All right, yeah, with the Allen wrenches, we can actually take this apart. This side here, it's another wizard that's covered on the on-screen computer where we would find our roller bath, things like that. Kind of gives you access to that roller wheel where this bath, small little bath with a razor blade, that razor blade actually makes contact with the roller, scraping off any excess that builds up during the print. Every so often with certain support materials like the support 706B, which is a pretty popular support material, it gets kind of gummy, builds up in this bath. There is a hose that goes into this bath to suck it out, but if you're using some of those certain materials, like 706B, this is something you'd want to inspect every so often. I'm not going to be able to cover every support material, every printing condition, but if any of these things sound familiar, any of these issues you're having sound somewhat familiar, oh, we're always gumming up material, we're always having this happen, reach out to any of us. We can get into more specific details, but I'm just trying to be a little bit more comprehensive and overall with this presentation today. One other cool thing I like to do is that hose that goes into that roller support bath, that overfill bath, want to keep that clean, make sure it's constantly removing the excess material building up in there. There is a hose that goes down into it. I'll take one of my caps or some other similar small size container, fill it with some isopropyl alcohol, put that hose into that container and let it suck up some of the alcohol and clean out that hose from building up and getting gummed up inside of the hose as well. All right, switch back to PowerPoint. All right, let's talk about support removal now. And at the same time, I'm going to try to roll over to our support removal area. So lots of different support materials out there, as you heard me just mentioning a moment ago. So there's a lot of different ways to remove it, some requirements for special materials. Try to give you, once again, a comprehensive overview. If you have more specific questions, feel free to let me know. So for FDM, we talk about wash tanks, a lot of different sizes, capabilities of these different wash tanks, but there's three kind of methods they're using, up to three methods they're using. So we have chemical, we're using a sodium hydroxide solution, which reacts with the support material and dissolves it. We're heating up to a temperature, right? And that temperature can vary depending on what support material you're using. We have some sonic pulsing, right? Just some vibration to kind of percolate things, get it moving, and cleaned as quick as possible. We have some hand tools, so pliers, other, just quick bulk removal, ripping support material off. For those wash tanks, we talk about part cages. So sometimes we have really small parts that we don't want to let fall to the bottom of the tank. Sodium hydroxide it's a little unfriendly. If your hand or skin is exposed to it for too long, I do not recommend it. Won't kill you or anything, won't send you to the hospital, but we want to avoid that. So we talk about part cages to put small parts in. We can sometimes have a chain coming to the top of the tank or some other way to remove that part cage without digging into this material or swimming into this material trying to find our parts. If we're using these wash tanks, we're using the Waterworks, sodium hydroxide solution. Depending on what state you're in, what your local regulations are, this isn't something you can just wash down the drain once it becomes saturated and neutralized and not dissolving your parts anymore. So we talk about acid neutralizers. It's a very basic liquid. So we need to, depending on your state, once again, I'm in California, so I probably have it as bad as anyone for regulations. So got to buy an acid neutralizer, neutralize that liquid. Now it's safe to flush down the drain. And in order to ensure that, we talk about pH strips, right? Being able to measure that value and know it's safe. On the PolyJet, we have a different cleaning method. We talk about water jets, right? High pressure nozzles to remove some of that for rigid parts, right? To just kind of water that off. But just like with FDM, before I put something in the tank for FDM, I want to remove as much support material manually as possible, right? Within reason. Don't beat yourself up. Don't spend forever, but make your tank last longer, right? Don't throw in support material when you don't need to. Same idea on the water jet. I'm scraping stuff off as manual as possible to start and then take it into the water jet kind of for some finishing cleaning. For hand tools on PolyJet, just dental tools work really well for the small delicate parts, right? Getting in there and scraping out some material. Yeah, just big scrapers, big putty knives and things like that. We also have a kind of soaking solution for the PolyJet side as well. There is just like the Waterworks sodium hydroxide solution, we have a CleanMore 706. It's one of many out there, but that's for cleaning, for instance, flexible PolyJet parts. Spraying them with a water jet could potentially damage them, rip them, so soaking is a better option to not destroy your part. I mentioned washing machine here, simple water, nothing else in there. And WSS in parentheses is water soluble support. So very, very delicate parts that I can't water jet. I need a more rigid support structure to ensure accuracy, part quality. We have water soluble support now on the PolyJet line, and a simple washing machine, water agitation. It is purely water soluble, no chemicals needed. So something else to consider if you're in the very delicate, very fine feature PolyJet side of things. Sponge and Brillo pad, right? Once the water jet is done spraying our PolyJet parts, you can always take your fingernail, scrape across a part and get a little bit more support material off there. I like to use a sponge or a Brillo pad with the tiniest amount of dish soap. Really seems to get that final little layer of support material off. And then lastly, a floor drain for either one of these systems, honestly. Really can make a big deal if that's something your facility could facilitate or have installed. It can really make life easier, so you don't have to carry buckets back and forth or anything like that. Especially on the water jet, just letting that water drain out. As I mentioned, on the support tank or on the support removal tank for FDM, depending on what support material you're using, there's different temperatures to consider. To set that tank to quickly clean it. Just a quick picture of that. This is the citric acid I use to neutralize my FDM wash tank, and just the pH strips, both ordered on Amazon, quick and easy. And a little bit more on post-processing. I'll just say a general disclaimer, break our color scheme for GoEngineer here in a bright red. Always consider your PPE, right? Whenever you're doing any of these other processes, there's sometimes gases or just different things to consider and you want to be aware of. So, but some of the different methods for post-process on FDM, vapor smoothing, I've seen a lot of do-it-yourself kits, a lot of videos on YouTube, really taking those FDM rigid kind of outer shell where you can really see the layer lines and really blending those, giving a high quality look. We obviously have sanding, painting, machining. On the PolyJet side, water sanding is a great way to make that part look nice and smooth. Plastics polish for removing scratches. Really good on the clear parts, right? We have clear Vero material on the PolyJet machines, so really wanted the high optics. And I might have another poll question here. Yeah, I can launch that while I talk. Just asking, what are some of the post-processing technologies you're currently using? I'm sure for FDM and PolyJet, a lot of you are using wash tank and water jet. Is anybody else going a little bit further than that, right? If you are going further than that, answer with those responses. You can skip the simple ones and go straight to any more advanced method you're using. So once again, on the Vero Clear, to really get those high optics, we talk about plastic polishing to remove scratches, clear coating with some enamel spray, alcohol wipes to, usually comes before all of this, kind of prepping that surface, getting it as clean as possible. And then lastly, with some of the newest, like Vero Ultra Clear, there's another side system, another unit that you can buy with those machines that does photo bleaching and really brings out a lot of clarity in the in your clear parts. That's cool to see. Some people are doing vapor smoothing and alcohol dip and wipe, so that's cool. All right, let's see here. A couple other machines. The Onulus wrap we see there is a great way for curing your waste resin off a PolyJet machine. Kind of prints it on that cardboard core we see to the right. And right next to that Onulus wrap is the photo bleacher. That's once again bringing that optical clear, or pro bleacher, but yeah, it's a photo bleacher. Brings some optical clarity to your clear parts. So that Onulus works with SLA materials, PolyJet materials, really good for not having to take your liquid PolyJet waste and go through the California EPA, which is, let me tell you, a whole lot of fun. So once it's solidified, though, it's valid to throw in the trash, right? It's no longer a toxic material. That's cool. It's nice to see a lot of people are doing some more advanced post-processing. All right, let's see here. To the machines. All right, so yeah, we have our simple water jet. I have a really fortunate setup here. So we got our water jet system here. I have a drain tank into that plastic bin on that first shelf. It's got a grate in there, so all my kind of residue goes down in there. Water still filters out down the drain on the floor that you can see down in that corner. And once enough PolyJet support material builds up in there, I just lift out the tray, throw it in the trash, and really good system. Got my sink. I have my Omega Sonics 1900 right here. This is my FDM support removal. It's got a nice big cage in it that I can pull out really easily without having to put my hands into the water. A little further over there in the back on the sink, if I can make it without losing my cord. Got my part cages, right? For my nice small parts that would fall through the big spacing on that bigger dump cage there. So all pretty cool. Let's come over here a little bit further. So over here, you can see my whole smattering of post-processing stuff, my crystal clear enamel, turtle wax for scratch removing, a Cleanmore 706 support removal for the 706B PolyJet support, some pH strips, my Waterworks sodium hydroxide solution. So yeah, on the post-processing side. All right, try to wrap this up a little longer than I wanted to go. No biggie though. All right, material handling. So a lot of people have material just thrown on the shelf, not taken care for as good as it can be, but with some really cheap investment, you can really make sure you preserve some of your more expensive materials, make them have a longer shelf life. So with both FDM and PolyJet, you want to avoid moisture, heat, and light, right? Keep it out as much as possible. On the FDM side, we can use things like Mylar bags and desiccates. All of these reels of FDM support material that come have desiccates kind of inside them already. And if you have a wasted container that's done, sometimes take out those desiccates, throw them in a Mylar bag with your other materials, keep it as dry as possible, keep that quality up. We can actually build a dry box as well, something you see in like woodworking a lot, to keep the material, once again, as dry as possible. And on the PolyJet side, it's all kind of the same idea, right? Avoid all these different moisture, heat, light, but those containers are pretty well protected by themselves already. Richard shared this picture with me. He built a really cool dry box, do it yourself, with some heater bars in there, kind of a humidity and temperature monitor. And you can see he's got his nylon 12 CF canisters in there, and that's one of the most expensive materials. And you know, he spends $100 to protect several thousands of dollars worth of material. So it's a pretty no-brainer if you're working with some of these more expensive materials and find yourself losing quality due to moisture and things like that. All right, to the machines one more time. Just one or two things to show you. Those Mylar bags I mentioned, right? Really great for sealing your FDM materials inside of. You don't want to just leave a reel open like this. It'll gather moisture, it'll bubble as it comes through the print head, and you'll see that quality affected in your print. PolyJet material, already fully sealed off, Mylar bag, keep your caps on there. All right, but pretty well protected already. And when it comes to these FDM reels, you can actually release this inner ring and see the desiccates already packed inside of there. So those could be reused potentially, right? If this reel never did anything except show up to my place of work, go straight in the machine, print until it's done, well, those desiccates are probably still pretty effective and can be use to preserve and prolong the quality and life of my other materials. All right, probably a bunch I forgot to say, probably didn't cover everything, but we'll call it there. Pretty much showed you 95% of what I wanted to discuss today, just a quick comprehensive overview. Really appreciate everyone coming. I'll hang out though for a few more minutes, and if anybody has any questions, go ahead and type them in, let me know, I'm happy to help. As always, you have my email, so feel free to email me anytime, let me know if you have any questions, and yeah, thanks again.